Hi everyone. So today we are going to talk about completing the square, and that is very important topic for us when we're going to talk about something called conic sections. So this is a review and an introduction of something that we need to know how to do before we talk about conic sections. So first, let's discuss what a conic section is. So here we have some examples of conic sections. It's basically if you have two cones stacked on top of each other, you can get different shapes by cutting these cones with a plane, and we can get the following shapes. Like this one right here is a parabola. If we cut the cone straight across, then we'll get a circle. If we cut it at an angle, we'll get an ellipse. And if we cut it straight down, we get a hyperbola. So through the course of our next unit, we will talk about all of these conic sections in details, and we'll discuss the applications. There are a lot of very important applications, but before we discuss these conic sections in details, we have to learn how to complete the square. Here's the reason why we need to do this. So if we're gonna discuss parabolas, for example, which would be fairly soon, we have an equation of the parabola written in this form. That would be called the expanded form. So notice we have, it's a little bit different from what we are used to seeing when we discuss parabolas. We're used to seeing y equals to some quadratic expression. This is still quadratic with x being squared, but all of the terms are on one side. Well, then we can rewrite this expression in what's going to be called a standard form. So a standard form is a form like this. We will discuss the full standard form when we discuss parabolas in more details, but this is an example of a standard form. So how did we get from the expanded form to standard form? Well, you can see a little arrow and it says that we performed completing the square. So therefore, by completing the square somehow, which we will discuss today and in the future, specifically for parabolas, we can rewrite our expanded form in a standard form. And from the standard form, there are a lot of things that we can find that will help us to graph parabola and find parts of the parabola. So completing the square is our main topic today. So completing the square is directly related to binomial expansion formula, formula that we've seen before. So if you have a binomial that is squared, then we can expand it in the following way. So really quickly, I'll show how this works. So let's say we have a plus b squared. Then it's the same thing as a plus b times a plus b again. So we know that squaring a binomial needs to multiply it by itself. We, of course, distribute everything. Well, if we distribute everything, then we will end up with a squared plus ab plus ab plus b squared, and overall a squared plus 2ab plus b squared. So knowing this formula helps us to expand binomials a little bit faster rather than multiplying them by themselves. So for example, if we have an example 1, if we have 3x minus 5, the whole thing squared, our 3x is going to be our a term. So this is our a. 5 is a b term. And now notice we did not include the negative as part of the b term because this minus sign, well, whatever the sign is between these two terms, that's going to be the sign right here in our expression. So based on our formula, we'll have a squared plus 2ab plus b squared, except this plus will actually be, in this case, whichever the sign is we'll have in the middle. So in this case, it would actually be a minus. Okay, so then our a is 3 squared, so it's going to be 3x squared. Actually, I'm going to erase this. Okay, so we'll have 3x squared. Then whatever the sign is between 3x and 5, that's what we're going to have here. So it's going to be minus. Then it says 2ab, so it's going to be 2 times a, which is 3x, times b, which is 5, and then always plus at the end, 5 squared. And then we can simplify everything. So 3x squared, remember to square the 3 and the x, so it becomes 9x squared minus, then we multiply 3 times 2 times 3 times 5, which is 30x, and then plus 25. So that is our expanded form. Okay, so once again, it looks like it's a little bit longer than, or at least not shorter than just multiplying 3x minus 5 by itself. But if you practice with this, you don't need to do the first step where I wrote everything out. You can easily just write out the final result by doing the middle step in your head. So therefore, whenever we have an expression that is in this form, we call it a perfect square. And we call it a perfect square because this formula will also work backwards. If we have an expression in this particular form, the already expanded expression in this form, then it will condense to the binomial of this form, a plus b squared. And it will be a plus or minus depending on what sign we have right here, of course. So therefore, if the expression is in this form, it will become a binomial squared. So for example, let's say we have the expression 4x squared plus 20x plus 25. So at close examination, we notice that 4x and 25 are both perfect squares. So that gives us an idea that maybe it is already in this form, and it is. So it's the same thing as 2x squared. 25 is the same thing as 5 squared. So now notice that the middle should be 2ab. Well, our a is 2x and our b is 5. So therefore, we actually do have plus 2 times 2x times 5. Let me write this still nicer. So it's the same thing as 2 times 2x, which is our a, times 5, which is our b. And please remember that 25 was, oops, I should write it was not as 25, but 5 squared. So we can see that this is our b, and then in the middle, this part is 2ab. So therefore, knowing this, our result can be written as a binomial squared. The sign in this binomial will be plus because that's the sign that we have here in the middle. And then it's going to be a and b. So our a is 2x and our b is 5. Now, keep in mind that it's possible only if this form is in ax squared plus 2ab plus b squared. So it has to be perfect like this. And then we can, instead of factoring the whole thing, this is a perfect square, so we can write it as a squared binomial. However, a lot of times we don't get perfect squares. So this is an example of a perfect squared trinomial, but it's not always going to be like that. So if quadratic expression is not a perfect square, then we can find a new constant number. So the new constant number. So basically, we're going to be looking for the number at the very end such that the quadratic becomes a perfect square. And that process is called completing the square. So here I'll give you a quick explanation of how we can find it. We'll see if we, so how we can derive that pretty simple formula. So in order to do this, we have, let's say we have some kind of a expression in the form So let's say it's in the form x squared plus bx plus c. Okay, so that's your kind of a standard quadratic form. Now, usually in the front we'll have a, but we're gonna consider our a to be 1. Okay, then we basically want to make sure that this expression is also in the form of a squared plus 2ab plus b squared. So in other words, our c term, that's why we're going to call it finding the c, that has to be a very particular constant, the constant that satisfies the perfect square. So that constant should be a squared number that follows the 2ab in the middle. Okay, so we need to isolate it. So therefore, we're gonna get our 2ab, and we need to isolate this b. So we'll divide both sides by 2a. So it becomes b, and then we'll have to square it, make it b squared. So therefore, our c term will be in the form b divided by 2a squared. So therefore, our formula for c will be b divided by 2a squared. In most of our cases, our a would be equal to 1, so we'll even make it more simpler. For our cases, it will be b divided by 2 squared. There will be situations where the a will not be 1, but we will deal with them when we get there for our purposes. Okay, so right now, knowing this formula, let's just complete the square. So we're finding what we call a constant c term, because once again, we are finding this number right here. So that number will be responsible for making our quadratic into a perfect square. Okay, so we're gonna find that number, and then what we say, condense our expression, or in other words, rewrite it as a squared binomial. Okay, so we basically want to know what goes right here. Once again, we are using the formula c equals b divided by 2 squared, and our a is 1, our b, here the big B, so maybe I can even write it like this. Our b is 10, and we need to know this c term. Okay, so this is going to be 10 divided by 2 squared, and that is, of course, 25. So we can put 25 here. So now this is a perfect square, and I can show you really quick. You normally don't need to show this, but the perfect square, remember, should be in the form a squared plus 2ab plus b squared. Okay, so in our case, our a is 1x, our b, we just found this, is 5, and then 2ab would be 2 times 1x times 5, which is 10x. So notice we do have a squared, which is 1x squared. Then we have 2ab, which is 10x, and then we have b squared, which is 25. Okay, so we have all of these parts. So therefore, this is a perfect square. Now, how do we condense it? So remember, this perfect square formula condenses into a plus or minus, depending on what you have right here, b the whole thing squared. So therefore, our quadratic expression could be rewritten as, we basically take a square root of the first term, so it's going to be x then whatever sign we have between those two terms, so plus, and the square root of the last term, which would be 5. And then we square the whole thing. So that is our condensed form. Okay, let's do 2 more examples. Okay, so we have x squared minus 14x plus some unknown term. So once again, we're finding this new c term, which is taking the b term divided by 2 squared. So in this case, our b term is the middle term, which is 14. Notice I'm ignoring the sign. It doesn't really matter because it will be squared anyways. So it's going to be 14 divided by 2 squared. So that is 7 squared, or 49. So 49 is the number that we need in order to make it a perfect square. And now we can condense this, and the condensed form is going to be some binomial squared. We take a square root of the first term, which is going to be x, whatever sign we have in the middle, which is in this case minus, and the square root of the last term, which is 7. And that is the condensed form. Finally, we have x squared minus x plus this unknown. So keep in mind that this is 1. So our c term, once again, is going to be the middle term divided by 2 squared. So it's going to be negative. We don't need the negative there. So we're going to have 1 divided by 2 squared. And that is actually 1/4, because when you're squaring a fraction, you square both numerator and the denominator. So 1 squared is 1, 2 squared is 4. So here we're going to put 1/4. But when we condense it, once again, it's a square root of the first term, which is x, then whatever sign we have in the middle, which in this case is minus, and a square root of the last term, which is the square root of 1/4, which is 1/2. So we get this, oops, sorry. So then we have this condensed form. Okay, now let's continue and see some more applications. So one of the ways you've seen completing the square is to solve equations, quadratic equations, without factoring and without using quadratic formula. So basically what we're going to do is we're going to rewrite our equations in this form, and then by completing the square, and then we'll solve them. So notice we already have a constant term on the right side, and unlike other quadratic equations, when we're completing the square, you actually don't need to set it equal to 0. We're gonna, in fact, always move the constant term to the right side, because we need a new constant term, the one that will make our square a perfect square. So we need to find this number. Well, we're doing it the same way as before. So we're gonna call it c, so it's a b divided by 2 squared. And in this case, it's going to be 2 divided by 2 squared, which is 1 squared, which is 1. So we're going to add 1 on the left side. But keep in mind that we need to balance our equation. If we edit something on the left, we have to add the same thing to the right. So that's something that a lot of people forget to do. So we have to add 1 on the right as well in order to keep the equation balanced. Now we can condense the left side. So this is a perfect square, because we just made it a perfect square. So we will condense it to x minus 1 squared. So it's the same process as we've been doing before. You take a square root of the first term, so that's how we got x, and whatever sign we have in the middle, so that's minus, and then the square root of the constant term, which is 1. On the right side, however, we do have 3 plus 1, which is 4. So now notice we have it in the form that we were asked to put this in. X plus or minus some a squared equals b. So now, having it in this form, we can actually solve this equation. We can take a square root of both sides. Then we'll end up with x minus 1 equals, remember that you get positive and negative 2. and then you add 1 to the other side, but keep in mind you will have two solutions. It's going to be 2 plus 1, which is 3, and 2, and negative 2 plus 1, which is negative 1. So we get these two solutions. All right, I'm not going to do all of these examples. I will skip around and I will do example C right now. So in example C, notice our 12 is on the left side, but we don't want it there. We want to know a new constant term. So we're going to move it over first. So now we have x squared minus 6x plus this blank space equals positive 12. Remember, you, of course, will add 12 to the other side. And remember, since we're going to be adding number on the left, we will have to remember to add the number on the right. Now we need to find that number. So it's going to be 6. So it's our C term. So 6 divided by 2 squared, which is 9. So we add 9 on the left, but we also have to add 9 on the right. Now we're going to condense the left side into x minus 3 squared. On the right side, it's 12 plus 9, which is 21. And we take a square root of both sides. So we end up with x minus 3 equals plus or minus square root of 21. Sorry about that. 21. And then, of course, we have to add 3 to the other side. So therefore, we end up with x equals 3 plus or minus square root of 21. Okay, let's just do one more example. So for example, E, notice that we have to maybe rearrange some things. So first of all, we want to move 2x to the left, but this 11, the constant term, should go to the right. So therefore, we'll have x squared minus 2x. We're going to put a blank space there equals negative 11. And then we'll have to put a blank space there as well. So to find the term that goes into the blank space, we once again take the middle number. So it's 2 divided by 2 squared. And that is, of course, 1. So we add 1 on the left and we add 1 on the right. Then we condense the left side. So x minus 1 squared equals negative 10. And now from here, take a square root of both sides. X minus 1 equals, please remember that we now have imaginary numbers. So we take a square root of negative 10, which would be plus or minus I square root of 10. And then we add 1 to the other side. So we do get solutions here as x equals 1 plus or minus I square root of 10. Okay, so the last thing that we are going to discuss is how to complete the square when you have two variables, x's and y's. So we'll do some of these examples. So when we do this, we're basically going to complete the square separately for x's and y's. So first of all, I will rewrite this as x squared plus 4x and then plus the blank space for the x's. And then y squared minus 8y plus the blank space for the y's equals 8. But notice that we're going to be adding two numbers on the left side. So on the right side, we also will have to add the same two numbers. Now we're completing square for the x's. So we just take 4 divided by 2 squared, which is, of course, 4 itself. And for the y's, 8 or negative 8, doesn't really matter. You're going to be squaring it anyways. 8 divided by 2 squared, which is 16. So we add 16 here. Then, since we added 4 and 16 on the left, we have to add 4 and 16 on the right. Now we're going to condense first the x's. So that becomes x plus 2 squared. Then we do have a plus sign between from this y, so it will be plus. And we're going to condense the y's. So it's going to be y minus 4 squared. And on the right side, we just add up all of these terms. 8 plus 4 plus 16. So that gives us 28. So that would be the condensed form with two variables. Okay, let's do maybe one or two more examples. Let's do one. Let's do this too. So let's do B. Okay, so once again, our axis, I'm going to rewrite it as x plus 5x plus a blank space plus y squared minus 16y plus a blank space equals 10, and then two blank spaces. Okay, so for the x's, it's 5 divided by 2 squared, which is 25 over 4. So we're just gonna leave this as a fraction. For the y's, it's 16 divided by 2 squared, which is 64. So it's 8 squared, which is 64. So on the right side, we're gonna add 64 and 25 over 4. Okay, so then when we condense our x's, it's x plus square root of 25 over 4, which is 5 halves, the whole thing squared, plus y minus square root of 64, which is 8 squared. And on the right side, it's 10 plus 64, which is 74, plus 25 over 4, which is 74, 79, and no, 80 and 1/4. Okay, and then this is your condensed form with two variables. Okay, the last one that we'll do is C. So here, notice that we first of all have to take this constant term and move it over because we don't want that constant term there. So therefore, we have x squared plus 24 24x plus a blank space plus y squared minus 4y plus a blank space equals negative 70. So we're gonna do the same thing as we've been doing before. Take the middle term, which is our b. So 24 divided by 2 squared, which is 12 squared or 144. And then negative 4, well, once again, it doesn't matter if it's negative or positive because we're gonna square it. So negative 4 divided by 2 squared, so it's gonna be negative 2 squared, which is 4. But please don't forget that these two numbers have to be also added on the left side. So we'll have to add 144 and 4. So then the left side, we can condense this one, x squared plus 12. Oops, this x should not be squared. X plus 12, the whole thing squared, plus y minus 2 squared. And on the right side, we just add everything together. So negative 70 plus 144 is 74, plus 4 is 78. And that is your condensed form. All right, I think that here we can stop. So once again, all of this is actually going to be very important to us in the future lessons. So it's very important to know how to complete the square, especially how to complete the square with two variables. That is a big part of what we're going to be doing in the next several lessons. All right, I hope you enjoyed the lesson and good luck.